So next is factors influencing transducer choice. Means when you want to like select a transducer, some factors will be influencing, right? So factors influencing transducer choice. Whenever you're selecting a transducer, which factors can influence you, right? So for the first one is the operating principle. Without checking the operating principle, you can't just blindly go to a transducer, right? So in case one or more transducer principles are capable of generating a satisfactory signal, decision is to be taken whether the to employ a commercial available transducer or build a suitable transducer. That's what we should decide. Means whether this is useful or this is just possibility. So it depends on the operating principle, right? So at the same way, the second one is operating range. What is the range of it? Because if you want 10 volts, if it is just giving 5 volts, it can affect you, right? So the range of the transducer should be large enough whenever you are selecting. At the same way, you should talk about the sensitivity. Is it very sensitive, or it is capable of high voltages, or whatever it is? So you should check the sensibility of the element also. Okay. At the same way, you should check about the accuracy. Is it giving us accurate value or not? At the same way, you should check whether it is having cross sensitivity. Means whenever we are using the actual quantity and our measurement is in one plane and the transducer subjected to variates to another plane, then we should see when we are crossing it, means whether it is sensible or not. Then physical environment. Sorry. So we should check the physical environment as well. The transducer selector should be able to withstand the environmental conditions when it is hot, when it is cold, wherever it is. It should be able to withstand while we are carrying the experiment. Okay. Then errors. So usually when you are calculating, obviously errors is a common thing. So when you are operating the transducer, the errors which are caused by the environmental conditions should be small enough. They shouldn't be very high. At the same way, you should talk about the transient and frequency response. The transient and frequency response means the transducer should meet the desired, like time domain specifications. What do you mean by time domain specifications? Means, for example, when I switch on a fan, it should first start with a 0. Slowly it should go to its speed and it should attain its maximum speed. But because of the environmental conditions, maybe your room is very hot, it can't give you maximum speed, but it will remain at particular speed. Maybe your fan can give 10. Now it is giving just 8, but will remain with 8. These are called as time domain specifications. Means whenever you choose a system, it should start from 0 and it should settle at some point without giving you more of the errors. Like that. Okay. Then loading effects. So the transducer should have high input impedance and low output impedance. It means impedance on the input side is always high, impedance on the output side should be always low, so that there is no loading effect. Okay. So then insensitivity to unwanted signals. So whenever there is an unwanted signal to the transducer, it should be very insensitive. It shouldn't affect the output. Okay. If it is affecting the output, obviously it is going to affect the whole system. So some unnecessary signals in the system shouldn't affect the transducer. Next is electrical aspects. So usually the electrical aspects which are considering in when you are selecting this transducer, like what is the length of the wire you are using, means the cable, what is the length of it, how it is going, all this also should be considered. Then the 12th one is stability and reliability. So when we are talking about basic requirements, there we were talking about this. It should be stable and reliable. Same thing here it applies. Always the reliability high and stability should be operating the system very pleasantly. Next, usage and ruggedness. So whenever we are using, it shouldn't be like very sensitive. It should be capable of withstanding the load. That's what we said at the beginning. When we are talking about basic requirements of a transducer, we said ruggedness is very important because it should be capable of withstanding overloads. Okay, so basically when you are selecting a transducer, all these should come into your mind, and then only you can choose the transducer, because that is not a straight element. For example, when you are selecting an voltmeter, it's a direct element. You are just giving an electrical input, it is giving you an electrical output, that's it. But here transducer is like, it is converting one form of energy into another form. Like temperature is converted into electrical unit, and then only it is displaying the temperature. So this conversion, it's not easy. So when you are selecting a transducer, all these should be coming into your mind. Depending on this only, you should select the transducer. Okay.